So hi and welcome to Global Azure 2022 and my session. Together we're going to be exploring Azure Cognitive Services containers. I am Georgia. I'm going to be with you for the rest of this session. I'm a Microsoft technical trainer at Microsoft. But before I joined Microsoft, I was very passionate about AI. I was a Microsoft AI MVP. I'm still a Microsoft certified trainer, but my background is mostly in software development. You can definitely follow me on LinkedIn, follow my blog, codestories.gr, or follow me on Twitter for any AI and tech related news. So for this session, we have a lot to cover. We're going to talk a little bit about artificial intelligence, what Azure Cognitive Services APIs are. For those of you who are not very familiar with virtual machines or containers, we're going to talk about what are containers and the general benefits and why we use them in comparison to virtual machines. And then we're going to talk about cognitive service containers, how they are deployed, all the information you need, and of course, we're going to see all of that in a live demo. So, without further ado, let's get started. Let's talk a little bit about artificial intelligence and Azure. What is AI or artificial intelligence? Essentially, AI is any technology that appears to emulate human performance and capabilities. For example, visual perception. Right? So it can take visual input and understand it and analyze it. Text analysis. It can understand and take text, analyze it, and even synthesize text. Same with speech. So it can understand speech, it can transcribe speech, and generate speech. And it can also make decisions, learn from experiences, and draw conclusions. Anyway, artificial intelligence is pretty much any technique that enables computers to mimic that human behavior. So we have machine learning, which is a subset of AI techniques that mostly use statistical methods to enable machines to improve with experiences and learn, from past knowledge. And a subset of ML is deep learning, which has more advanced learning techniques, which makes computation of multi-layer neural networks feasible. What does that have to do with Azure? Of course, Azure offers a lot of options when it comes to AI and machine learning. It also has Azure Machine Learning, which is the machine learning platform of Microsoft, where you can use that with your data to create your own models. But that requires a lot of expertise, data science, algorithms, and even mathematical knowledge that not all developers possess. Or maybe you do want to have AI-enabled apps, right? But you don't want to invest that hard, if you're just getting started. So this is where Azure Cognitive Services come. These are prepackaged APIs that you can use to integrate into your application without any machine learning knowledge or any data science expertise. You just need to know the basic, and you can use your favorite programming language to use them. So essentially, you don't need to train any models. Everything has been done for you, and you can use any of those APIs in language, speech, vision, and decision categories, right? So you can do text analysis. You can use the translator services, language understanding, question answering solutions, right? In speech, you can use speech to text, text to speech, translation and recognition. For computer vision, you can analyze images, and you can also create your own models to analyze images. But even custom vision, that you need to train your own model, provides a portal that makes it very easy for someone just getting started without a lot of expertise to go through that process, right? And also in the vision category, we have face recognition. And then we have the decision category. You can use the anomaly detector to detect anomalies in your data, the content moderator to moderate your content and find if there is, profanity in speech or in text or racy content or any kind of other inappropriate content. Let's say, and then you have the personalizer service, which you can use to analyze feeds and create personalized feeds. We also have some applied AI services like the form recognizer, like the bot framework, but they all work similarly to this. You have your API and it's ready to integrate it. How, you might ask? So the integration is very, very easy. All you have to have is an active Azure subscription. As soon as you have your active Azure subscription, you have to create a cognitive service resource, that's what it's called, and get an endpoint, this is a URL, and a key. And then you can use that endpoint and key to connect your application to the API and send and receive data. Of course, in order for you to do that, you'll have to have full network connectivity. That means your application must be connected somehow to the internet and can reach Azure for this send and receive data process. And beyond that, all you need is your favorite SDK or REST interface. The service supports a lot of SDKs. So there's an SDK for C#, Python, Java, and a couple of others. And even if you don't have an SDK for your favorite programming language, you can definitely use the REST interface and create any language to make a REST request to send the data and get back the results. So the process works, as we can see, on this graphic on the right. So you have your application here, this little square. You send a request with the data you want analyzed. So for example, you might have an application that has image analysis. So here you'd send a request with the image. The service will analyze the image and reply with a response with the results. So for example, you might send an image of, a mountain, right? And it will respond with anything that it recognized in the image. So for the mountain, any landmarks, colors, content, and everything. So that's how easy it is to integrate your application with those APIs. But there's a key I don't want to say limitation here, but it is. You need to have network connectivity, and you also need to be able to send your data into the cloud. Okay? But sometimes there's a need for hybrid scenarios. So, for example, let's say we have a scenario where connectivity is not guaranteed. So you have a ship that sails throughout the world. It can be in the open seas. So sending images or video streams up to the cloud is not an option at all times. Right? So that can make your work a little bit difficult. But even if connectivity is not an issue for you, there are several applications and areas where data are very sensitive. And for some countries, there are legislation that do not allow you to send those data into the cloud. For example, in the medical sector, patient data are very sensitive. And for a lot of cases, they're not allowed to be uploaded to cloud services. So although, we have a lot of functionality available, there are scenarios where we need either on-premise analysis or we need to preserve the data residency. Okay? So this is where Azure Cognitive Services containers come to help you. Okay? So let's see how containers work. So for anyone who has never worked with virtual machines or containers, so this is a little bit of a comparison. On the left, we have an image, this image here, where you can see, virtual machines. Essentially, what containers do differently than virtual machines is that they provide a layer of isolation. So let's see this scenario where we have a web application. Okay, and we need to set this up somewhere in the cloud, okay, or on a premise server, it doesn't matter. But we have a web application. So in order to do that using virtual machines, we need to have the infrastructure. The infrastructure can be an on-premise infrastructure or a cloud infrastructure. It doesn't really matter. Okay, and then you must have kind of a virtualization technology. In this case, we have the hypervisor that you use to, create the virtual machines and share resources from the infrastructure, and then you set up each individual virtual machine. So each virtual machine must have its operating system that you must set up properly, and then on top of that you have to apply all the libraries and SDK for your application to work. If it's a Windows machine, you need to set up the IIS to host your application and do a lot of configurations, right? What happens when you want to change virtual machine, or even worse, when you want to change operating systems? That's not always feasible, right? Because an application that's built for a specific operating system cannot be changed so easily, depending on the technology it's built on. So you have a limitation right there. So you kind of you're married to the operating system and the infrastructure that goes with it, which is not a huge problem, but it can create delays in case you need to close that virtual machine or transfer your infrastructure, right? So what containers do, and let's look at the right image here, is you have your infrastructure, right? Same thing, you can be an on-premise or a cloud infrastructure. On top of that infrastructure, you have your host operating system, okay? And on top of that operating system, you have a containerization technology. For example, Docker or some others we're going to see. On top of that technology, you're setting your containers, or images as we call them. So you can have multiple images, multiple containers in one infrastructure. And you pretty much have no limitation because those containers are pretty much isolated from everything else, from other containers in the same infrastructure. And they're not tied in any case to the operating system. So the app A here can be a Windows, not Windows, let's say a .NET web application, right? App B can be a Python application. App C can be a different kind of application altogether. So you don't need to have a very strict rule on how you set up your operating system and libraries. So each container, it's its own little world of your libraries and your app and everything that's needed for your app to run. So it provides a lot of flexibility if you want to move your complete infrastructure to a different operating system, because the images are OS agnostic. Let's say they don't know what's operating the operating system that lies underneath. It's the containerization technology responsibility to handle everything in between. So it provides a lot of flexibility. And it has a lot of benefits when you're transferring, infrastructures going from, let's say, development to production scenarios. So it has a lot of flexibility and it opens a whole world of capabilities, right? So how can we use containers? We can use Docker, we can use Azure Container Instances in Azure, or you can use Kubernetes for more complex orchestration needs. No matter which technology you use, the principles are almost the same. Okay? You have your image. That image contains everything for your application to run, and that's all you need to worry about as a developer. Okay? So it's very flexible, very easy, and provides a lot of benefits. So the benefits I'm going to show here are for general container benefits, but also Azure Container Services benefits. Because what happens when we use the Azure Cognitive Services containers is essentially we bring cloud functionality on premise, and we're going to see how that happens right after. So let's talk about a little bit why would we want to do that. So the first is we have immutable infrastructure. So you have a consistent and reliable set of known parameters, right? So you have your images, the libraries, and everything, but they're also very adaptable to change. So you have a whole ecosystem that you can use, change technologies without, hurting your applications or doing a lot of dev configurations. You have full control over the data. Okay, so this solves our problem that, if I don't want to send all my data to the Azure, what am I going to do about it, right? So you have full control over the data that goes into the container and full control of the data that are being sent to the Azure. So this is essential if you can't send data to the cloud, but you want to use the functionality cognitive services provide. So it can help you in hybrid environments, as I said, that you don't have full functionality or constant network functionality, or where there's data or legal issues involved. Another thing that we should be aware of is that you have full control over model updates. So Azure Cognitive Services APIs, what are they? They essentially give you access to a pre-trained model. So Microsoft has sat down and trained this model for you, which can do facial recognition, it can do computer vision, it can do speech to text, and all of those beautiful features. But this model constantly evolves, right? So every time we use the service, this service gets better, has new data on it. So, periodically, this service has model updates. Okay, but what happens? Usually, these are not breaking updates from my experience. Okay, so sometimes the model changes and you don't even see that in your application. But sometimes you need to change your application depending on the model used by the service. In that case, when we're using containers, we can choose which model the container uses and stick to it until we're ready to update to the next version. So this is something that cannot happen in Azure service. In the service, you can rarely choose which version it's on. Usually the service provides you with the latest and the best version. So if you have a need to control release of model updates, you can use containers to do that. Okay. As I've said, the architecture is portable. What does that mean is that it can be deployed on Azure today, in an on-premise infrastructure tomorrow, Docker today, Azure Container Instances tomorrow. You don't have this limitation of, the operating system together with the infrastructure. Okay? Of course, when we're talking about AI, that means data, and usually means a lot of data. So you might have different requirements from processing that amount of data, and you can configure your containers for high throughput and low latency. Okay, so containers don't cap transactions. What does that mean? So essentially, when you're using the container services APIs, you're charged by each call you make to the service for most of the services. There's a little bit of a differentiation, for example, speech or speak to text, where we have audio files maybe. So you might have a little bit of a difference there. But in most of the services, you're charged by how many calls you make to the service. And this is not unlimited. The service has a cap of how many requests it can handle per second. So when we're using containers, we don't have a cap. It depends on our infrastructure and how many calls that infrastructure can take. So you can have very quick transactions and computations to get results from the same service you would otherwise use on the cloud. Okay, so it scales out to the demand you might have. And also scalability. Okay, so containers and everything we talked about are built for scalability. Okay, so we've seen the features. Let's see how it works. So we talked about it in the previous slide. So this is the simple scenario. You have your application on the bottom here. Okay, and you make a request. Okay, to the service. The service does the analysis depending on which service you're using. So let's say, for example, you are using the speech to text functionality. So you're sending your request with an audio file that contains speech. The service generates the text and responds with the text. what happens differently to support those hybrid or on-premise scenarios? So you have your application, and the application sends data to the container host here. The container host is responsible to do the analysis and return the result to you. Okay, that's the biggest difference you're gonna get. Okay, and this icon on the right represents the image, okay, of the service. We're gonna talk about that a little bit later, but in order to build that image, you have to download it. The images are ready, made for you. Okay, you don't build them yourself, so you have to have the image, and everything happens in the container. But you can see that little dotted line that goes up to the service, and you might ask, do I need connectivity to the service? Didn't we just say that everything is downloaded and I can use them in the containers? Well, yes, but Azure still needs data regarding billing and logs and metrics. So even though you're not sending data directly to the Azure, the container must have connectivity to the Azure. So even if the container, technology is behind some kind of firewall and it doesn't have access to the internet, it still needs to collect to two specific addresses. You can find them on the docs. So it can send some data about billing purposes and logging purposes. Okay, you don't need to have full connectivity, as with the service. Well, you need to send data to receive data. You can still use the service, let's say offline, but you still need to have limited connectivity to the service. Okay, but the data and everything else, all the analysis stays in the container, and all the interaction happens between your application and the container host. Okay? So, how do our prerequisites change? Well, not much. We still need to have an active Azure subscription. And we still need to have a cognitive service resource to get that endpoint and key, okay, to use the service. But we don't need to have full network connectivity. Okay, you need to have limited network connectivity, okay, to send and receive data to Azure for billing services, okay, and your favorite SDK or REST interface that you can use to build your model and do everything else to create or integrate all those services to your existing applications. Be aware, though, that although most cognitive services, okay, work out of the box, so you make a request and you get a response, there still are a couple of services that need you to do a little bit of configuration, okay? And for those services, and their containers, the containers can have their own requirements. So, for example, they might need to have specific RAM and core requirements to work properly. Or they might need to get some kind of reference to a model. An example of this is the language understanding. So in language understanding service, what you do is essentially you train a model to understand the intent of your user. And this is mostly used in bots. So the service can interpret what your user wants to say, and you can redirect them to the appropriate, let's say, article, or connect them to an agent, right? I think most of us do have experience with bots, so I'm hoping this is a scenario you are familiar with. So let's say you have a customer service bot. You usually say, hello, blah, blah, blah. I need to open a ticket. So the language understanding service is what could do the text analysis and recognize that the user wants to open a ticket and redirect them to either the ticketing system or to an agent. Okay? In that case, that little model you train is specific to your own scenario. So the container for the language understanding service besides a couple of requirements that we're going to see later, it also requires a reference to that model. Okay, so of course not all services are generally available at this point. So the ones in purple are still in preview. Okay, so the generally available images you can use to take off your cognitive services locally, let's say, or on premise, or in your favorite container service, are text analytics, language understanding, speech to text and text to speech, read, that's the OCR capability of vision, and for the decision, the anomaly detector. But in preview, we still have language detection when it comes to text and speech, some translator capabilities, spatial analysis, and it's not on the slide because it's an applied AI service. The form recognizer is still in preview. All the supported images with the requirements are very detailed in the Microsoft Docs, if you're interested. So we've talked a lot about the containers and the benefits. Let's see how easy or complex it is to deploy cognitive service container. First, you have to get the image or the container from a container registry. For example, you can use Docker Hub. This is what we're going to use in our example. Second, for a container of cognitive services to run, you need to have 3 required parameters: the API key, the billing URL, and the EULA accept parameter. So to get that service key and service endpoints, you need to have the cognitive service resource we talked about. Okay, and the EULA, you just need to put the word accept as a parameter. Otherwise, if your container configuration is missing those 3 components, it won't run, it won't do any computations, it won't do anything. Okay, and as I said, beyond those required parameters, you can definitely do more configuration, so you can allocate different resources, cores, etc. to your container. And depends on the container image, you might need to pass some kind of other information like the model, and in some cases the log output, so it can output the logs, maybe differently if that's what you want. So that's pretty much all. You run the container, and as soon as this container is ready and up and running, you are ready to use this capability. Okay, so the deployment process is pretty straightforward. Let's go ahead and see a demo of that whole process. So for the purposes of the demo, we are going to be using Azure Container Instances. Okay, so Azure Container Instances is an Azure service where you can upload your containers directly to Azure. But if you are more accustomed to using Docker, okay, you're more than welcome to use the same principles, the same process in order to create your containers in Docker or Kubernetes or anything else. Okay, you are used to using. Okay, so let's go to the Azure Portal. So this is the Azure Portal, which we're going to be using for our demo. Before we go to the portal, I mentioned a container image registry, the Docker Hub. Let's see what that is. Essentially, you come here, okay, and you can find ready images for pretty much everything. So if you want a container, let's say with Microsoft SQL Server, okay, you can search that container registry and it will bring up official images, official containers okay, with the technologies you want. So you can very easily create a container from ready images. So this is the Microsoft SQL Server, and it's been updated fairly recently, okay? And you click on that page, and you'll find the information for that specific image or container. Okay, you need to have a little bit of knowledge regarding containers. I'm not going to cover that in that session. I'm just doing a little bit of introduction here in case someone has never seen or worked with a container registry. Okay, so what we want are Azure Cognitive Services. So let's go ahead and search that. Okay, and this is the first result. Let's open that and go to the Azure Cognitive Services. Here, as you can tell, we don't have one image, we have several container images, as I showed in the slide as well. You have the speech service, the language, the decision, the read, and these are the containers on public preview, all we have seen, in the slide, and the form recognizer ones for several APIs. Okay. For our demo, what I'm going to do is actually use the sentiment analysis image. So what sentiment analysis does is you would give the service text, and it determines whether that text is positive, neutral, or negative in sentiment. So if it gives a positive message, a negative message, or a neutral message. So, hey, it's a lovely day would be a positive example. Or, oh no, it's a disaster would give a negative sense. Or neutral could be my computer just opened, so it doesn't really have any sentiment attached to it. It's just a phrase, part of text. So in our example, what we're going to do is create a cognitive service text analytics sentiment container, okay, using that image, and we're going to use the container to get results. Okay, so let's go back to Microsoft Azure. All you need for an image is essentially, this little, if you're using Docker, you need this whole command, but all I'm interested in is actually the latest image link, which is this little link here. Okay, so let's copy that and have it in our clipboard, and let's go back to Azure. This is the Azure Portal. This is where everything, all the products of Azure are held, so you can create new services and use services. Okay, so in our theory, the first thing we talked about is, cognitive services and how you need a cognitive service resource in anything you do. So let's go ahead and create our resource. We're going to use this. It takes us to the marketplace. And we're going to search for cognitive services. Let's put the result here and go ahead with the search. It shows us the the product and everything. We can a little bit of information if that's what you want. There are two ways to create those cognitive services keys. Okay, first you will create a cognitive services resource where you can use multiple services with the same key. But just as an information, just an FYI here for anyone who's interested, you can create a key for a specific service. So for example, if I wanted to use the language services like text analytics, etc., I can do language here, and it will find the language services or the language understanding. There's no difference in using different keys or the same key for everything. It's just for your personal organizational preferences, or if you have different customers or different applications and you kind of want to split the billing. Okay, so generally you don't need to do a lot of go complex into it. There's no difference. You can use either key for either purpose. Okay, so I am choosing a cognitive services key service, so I can use it with any service I want. and I can choose create here. It will take me to a form. As I said, you need to have an active subscription. Okay, you have to create a resource group. For those of you who don't know, a resource group is a logical unit of grouping here in Azure. So essentially is me grouping my resources. So let's say this is the Global Azure to demo. Okay, and I'm giving it a name. You choose the region. As a best practice, you choose the region closest to your user. Let's try West Europe. Okay, and then we have to give a name to our services. So we're going to do GAP 2022 Cognitive Service. And then we're choosing the pricing tier. Okay, and of course, when you're building anything in AI, you need to have responsible AI practices. So you mustn't be biased and operate together with, any techniques and Microsoft principles. Actually, there are 6 principles that you can use as guidelines to develop responsible AI applications. So if something that's that interests you, you can definitely research it a little bit more or use the online resources here. Okay, so let's go to the next step. That's identity. I don't want anything to do that. And the next is tagging. That's not a functionality I want right now either. So let's go to review and create to run the final validation. And all you have to do at this point is actually create that service. Okay, so the deployment is in process. I don't want to wait until that. Oh, it was fast. So let's go and work with the already deployed resource. Okay. So this resource has, the name I gave it, and based on that name, you receive an endpoint. Okay, that's usually name. And it has a specific suffix that says Cognitive Services, Azure Com. Okay, so to use that service, for example, if I had an image right now, or a text, and I wanted to do analysis, I would build my application, okay, make an HTTP request to the service by using that point and a key. Where do I find those keys? So keys and endpoint are here. Okay, you have 2 keys. There's no difference between them, just backup purposes and everything else. So you would use the endpoint and the key. In some services, you might also need the location, so it has it here added as well for your convenience. So that's it. Actually, you create that resource. You have your application that can make HTTP REST requests. The requests are usually in JSON, okay? So you send your data, right? And you get the response from the service. All you need to have is that endpoint and that key. You put it in the header of the request and you get the information back, okay? That's how easy to run cognitive services. So that's the first step when working with containers, because as we said, with containers, you still need that cognitive service. So now that we have that service, let's go ahead and create our container. So if I had a Docker instance, I would create a Docker container. I would pull the image from the repository and run the image with specified parameters. The process is very similar with the Azure container instances. So for convenience, right now we're going to work with the Azure Container Instances. Okay, it's a service where you can upload containers directly into the cloud. Their functionality is similar to any containerization technology you might want to use. So let's go ahead and choose container instances. I have some container instances ready here, but we're going to go through the process of creating one regardless. So let's create a container instance. Okay, same things here. You need the resource group. I'm going to choose the second one. Okay, I will give the container a demo, a name. So I'm going to do container. Okay, I'm going to choose the region and availability zones, no. And here you can choose the image source. For me, it's not a quick start image or any Azure container registry, is the Docker Hub we just saw. So I'm going to click on Other Registry, public or private. The Docker Hub is a public registry. Okay, and all I have to do is paste the image I copied previously. Okay, so this is the Microsoft image for the Azure Cognitive Services, and I'm reminding you that this does sentiment analysis. So you upload a phrase to the service and it tells you if it has a positive, negative, or neutral sentiment overall. Okay, you have to specify the OS type. I'm not going to change that for now. And here you have to change the size. So as I said, some containers in cognitive services have specific requirements. Okay, so you might need to change the size. So you might need to change the number of CPU cores. I'm going to put 2, and the memory. I'm going to put 4, just to make sure I have enough computation and memory to run, the model to get the results I want. Okay. Then we are going to go to the next tab, which is for networking. So when we're creating a container, essentially what it does is it creates an application, and that application is accessible via a port. Okay, same as any other application that's hosted, let's say, if it's a web application on an IIS on a server. Okay, same with a container. So here we can declare the port. So here the default is the 80. You can use a different one if that's what you want. Okay, and open up the protocol for the ports that I want. I can also give it a DNS name label. Okay, so in order for me not to use the IP for the container, I can use a more, friendly name. Okay, so I'm making the changes here. I'm going to go to the next tab as well. And here on the advanced, I'm going to put what we call the environmental variables. These variables are essentially the parameters that I'm going to use for my container to run. So we showed that slide previously. What I need is the API key, right? The billing, which is the endpoint, and the EULA accept. There are 3 specific variables. If I do not include them, the container won't run. Okay, so make sure you don't forget that step if you're using container instances or Docker or any other technology. Okay, and I can even mark them as secure. What does that mean? That anyone who views that resource in the portal does not have access to that information. So obviously the key is a secure value. So if I type something here, I can see it. But if I mark yes, then it's all deleted here. Okay, and 2 more variables, the billing, and as I say, the terms agreement, which only I put accept each time, right? And these are all the variables I need. Where would I get those values for the API key and billing? From the cognitive service I just created. So let's go back to the cognitive service, okay, to the keys and management section, okay, get key 1, and paste it here. Let me check that's actually a key. Yes, it's the key. And then let me get the endpoint as well and put it here. Okay, and it's the service endpoint. If you want more commands when the container starts, you can override the command here. Okay, if you don't, you can just leave it blank. Right? These are all the configurations you need to set up the container instance. All you have to do now is review and create. It will do a quick validation on the data, and as soon as validation has passed, you can click create to create the container instance. Okay, I'm going to create the instance, but usually this will take 5 or 10 minutes. So let's see, before we did this presentation today, I've already set up everything in a different container. So let's go and see how the end result would look like. So let me go back to Azure. Okay, and let's go to this container instance. After the process has finished that I just showed, this is what the result would be like. So you'll have the container instance here in Azure that you can manage. Here on the containers section, you can see the containers that you have active right now. So I have this one, okay, the state is running and the start time is a little previously. Okay, so you can see all the information. On the bottom, you can see the properties of the container. And if you click the properties, okay, you can see, you know, the ports and everything we've created here. And you can also see the environment variables. But the API key that I set as, you know, that's supposed to be safe, that's a password, is not shown here. That doesn't mean it doesn't exist. It means that it's just not shown here. Okay, and you have the acceptance. So basically we have everything we need for the container to run. So all we have to do is go to the overview. If we have a fully qualified domain name, that's usually in a form of, you know, name.container.azure.io. But because I didn't put a fully qualified name here, I am going to use the IP address and the port I have used. So if you go and follow that address, okay, it says that your Azure Cognitive Service container is up and running. That's the main page. Okay, so instead of using now the endpoint, okay, URL, you can use this URL to send requests to the service. But how are you sure that's work correctly? So the service and the API is accompanied by a Swagger file. So you can actually do that. You can type Swagger after the link, and it will get you to the Swagger interface, where you can see all the available APIs in that container, and you can actually use those APIs to query the service and get results to make sure that the service works and your container is up and running correctly. Okay, so the Swagger file loaded, that's a great indication that everything is up and running. But let's go to the ready here and make a small request. If you've never worked with the Swagger, you know, UI, it's very convenient and it's a very easy way to test your APIs. Most APIs are accompanied by Swagger in Cognitive Services, etc. But you can even, if you're working with .NET and other technologies, there are ways and packages that you can incorporate it in your APIs to, you know, do quick testing or during development. Okay, so let's test the service, see if it's ready. So this is a simple request. To try the service out, you click the Try It Out button. I'm hoping the zoom is adequate here for everyone. Okay, let's go try it out. And here there are no parameters, so I just execute that request and await for the result. So let's see what the response was. So the code was 200 and the response was that the service sentiment version 3 is ready. So let's go and see if it actually works with some popular phrases. Let's go to sentiment analysis. As you can see several versions of the model here. You cannot test previous, of course, like version 2, etc. But it has the version 3, and you can choose, you know, the sentiment or any preview versions for that if you're you know, doing development. Okay, I'm going to choose the sentiment version 3. Okay, here I have a couple of parameters. Okay, you can show stats. So you can get some statistics. I'm not going to put it, you know, it will make the response a little bit cluttered. Okay, and you can even change the model version of the request. I'm going to put the latest here. I don't want to change anything. So as soon as you try it out, okay, it has, you know, a you know, default document for you to try the service. So, hello world, this is some input text that I love, okay? Or it's incredibly sunny outside, I'm so happy. Or this place is my favorite Seattle attraction, okay? And as you can see, there's a specific format for each cognitive service, okay? For this, You usually send a text and an ID and the language, okay? And if you want a couple of others. So when the results are returned, it will return the results together with the ID that you sent, so you know which result matches which answer, okay? So these are the text. So, and this goes to the body, okay? And let's execute and see the results of that. Okay. Okay, so we got a bad request. Okay, let me just open the page and make sure I'm looking at the results and not, you know, the documentation. So these are the available responses. Okay, but this is what a valid result looks like. So you'll have the ID of the document, the sentiment, positive or negative. So here most are positive, right? And in addition, you get a confidence score. Okay, so what is a confidence score? So you send a text to the service, right? And that text can be positive or negative or neutral, right? But that doesn't mean that the result is, very specific or 100% correct. So the service just doesn't actually return an actual result. It just returns the likelihood of the text being either positive, neutral, or negative. So when you get a positive 99%, this is how it's translated. It's a value between 0 and 1. Okay, and this value is translated as a percentage. So this tells us that the first sentence we sent was positive, which it was like, it's an incredible day or whatever. I don't remember the exact sentence. It said that, 1% of it was neutral, but none of it was negative. So it gives you the likelihood of its result. So you can, tailor the responses and see if you get like a 50-50 somewhere. Make sure you do further analysis or something. But it gives you a pretty good idea of how the service works. And it also breaks down the sentence. So you get result for the whole phrase. But if that phrase has multiple sentences, it will get you the result of those individual sentences. Okay? So this is what the response would look like. Okay? So this was an easy way to work and try the service. You can try different results. You can get the status of the service, if everything's okay or if something's not working properly. Okay, and of course you can get the schema for requests and responses by using the Swagger interface before you even go and write a single piece of code. Okay, so essentially, this is it. It took us, I think, a little bit more. It will take you around 20 minutes to set up, taking into account any delays of the service. So, for example, when you're starting the container, it can take, up to 10 minutes. The cognitive service also might take 1 minute or 2 minutes to get finalized. So essentially it's very easy and very fast to spin up a container for cognitive services and start using it right away. Okay. It provides, as I said, a lot of flexibility. All you need to do, you create your cognitive service resource as you would normally do, but instead of using that endpoint and that key, you're pulling an image from a container registry such as Docker Hub. Okay, you're passing the parameters for the billing and the API key, so Azure can know how much use of the service you're doing, get metrics and everything. And then you can use that result, you can use that new link. So now you can see we have the, I don't know if you can see it very well, you have the IP and the port number, and you can use that IP and port number instead of the URL to get your responses. Okay? Very easy, very, very fast, and it helps us support a lot of scenarios when we have either data limitations, legal limitations where we're not allowed to upload data in the cloud, and essentially situations when you have connectivity to the internet but it's very limited and it does not allow for a lot of data to be uploaded and waiting for those results. So you do your computations locally, you're doing everything locally, you're still using Azure services, okay, you're still using cloud services, but everything happened locally, and you get the benefits of both worlds. It's the only suite that you can essentially bring down to on-premise, okay, so you can take advantage of all the functionalities. Okay? So, to sum this up, okay, today we talked about AI and how that AI is any software that mimics human capabilities. And Azure Cognitive Services APIs is the Microsoft AI suite. You can use that to create AI-enabled applications very, very fast without requiring any machine learning expertise. Okay? We talked about virtual machines versus containers. Okay, both have its merits, right? But in terms of flexibility and scalability, containers have a lot of advantages, and they're very fast to spin up and have very little configuration in comparison to virtual machines, because you can create containers by using a template file. So you create your configuration file, okay, your Docker file, and you spin up a container from scratch. Whereas when you're creating a virtual machine, although there is functionality in Azure to use templates for a complete infrastructure, you still have to do some configurations sometimes, regarding the operating system, and it's very difficult to do a complete change regarding applications and operating systems, whereas containers make that very, very easy. So we talked about the feature and benefits to using containers, and specifically container cognitive service containers. So data are stay locally. You can use the model version that you like. Okay, you have complete control over data and model updates, right? Of course, you have all the other benefits of containers like scalability, high throughput, and latency. You don't have a cap on requests as you would with the actual, the Azure service. So it provides a lot of flexibility and can scale up to your own demands. Okay, all you need is a cognitive service resource. Okay, the container image. You pass the required parameters, as we saw. You're starting the container, and all you need to do is run it, and you're ready to test the service and start developing the application to process the data. Okay. So thank you very much. That's it for today. I hope you enjoyed that session. You can still find me on LinkedIn or my blog or Twitter, or let me know if you have any questions regarding that session. Thank you very much, and hopefully you enjoy the rest of the Global Azure of 2022.